Let's start with the obvious question. Why use artificial intelligence in vision systems at all? And by that I mean, what benefits does it bring to machine vision specifically?
It brings just hype, right? No. So,
There's some of that going around with AI now. Yeah.
oh yeah, for sure, man. What a crazy storm we've been in like the past couple
Yes,
months. But
absolutely.
honestly, the technology in specifically in machine vision has been around a while. It's sort of yeah, it sort of started with like neural networks way back, I think in like the 80s. Now we're using them quite often. But the bottom line is, why do you want to use it? It kind of gives you another approach to solving qualitative problems, which can uh, sometimes be difficult for kind of the more traditional rules-based image processing approach to solve. Um, so what I mean by qualitative is let's take a really, really simple example. Let's say we have like a mixed fruit production line. We've got apples and oranges for some reason on the same line. And we have the problem, okay, we have to sort these. So you can start with traditional rules approach. Okay, we have an expert in machine vision go, how can I differentiate these? Okay, maybe there's some difference in color. Maybe the circularity is different between an apple and orange. An apple's got a stem. You can kind of continue on and on to kind of create these rules, and then you sort of end up having exceptions along the way, and this process takes quite a long time to come to a final solution. And that final solution, could be tested in the field and then end up not actually working. Um, so instead, with the most, I think it's the most common AI type of network called a convolutional neural network. With that type of network, you instead feed a big data set to it, basically. And big can be relative. It can be 50 images, can be 100, can be 1,000. And you feed, pictures of apples and pictures of oranges to this network, and you tell it which picture is an apple and which picture is an orange. And then that network, during the training process, figures out what you mean by an apple and an orange. So that's like one of the big things. You can get this kind of initial prototype out pretty quickly, learn from the field, and it's an alternative approach to some rules-based stuff. Yeah.
Okay. All right. Thanks for explaining, the generalities of how that works. Can you dig a little deeper, kind of give us more information about specifically how AI enables vision system use in quality control and assurance in manufacturing processes?
Yeah. So you can kind of you could take one of these networks and insert it to help a quality assurance or quality control process that a human can do alongside it. So it's again, networks like this or AI like this is good for qualitative things. Is there screws missing on this part? Oh, I only see 3 out of 5. Okay, that's a bad part. Oh, this part's a little askew. Things like that, it can help a lot in seeing. And yeah, there are like a couple different like network architectures, I guess you could call them, or like methods almost. There's object detection, which stuff is like, again, counting those screws. There's classification. In the case of like mixed use lines, it can say, oh, this is this part. Let's switch the system to what that part needs versus all of the other parts you have running along the system. And then there's also segmentation, which is it's still useful in quality assurance, but it's sort of one of the steps into using maybe some other techniques. So that one's a little harder for me to explain off the bat. And then finally, there's a really powerful one called anomaly detection. Those types of networks, uh, instead of having like this giant data set of like good and bad images that you have to provide like a quality control process, which is tough, right? Most modern manufacturing has a pretty good yield rate, right? So you end up not having, even if you decide to capture data of like all your parts, you end up having way more examples of what a good part is versus what a bad part is. And those bad parts can vary quite a bit in what they are. Like maybe it could be like a scratch on a metal piece or the metal piece is cracked. Those are already two different types of anomalies that would need examples in kind of more of a classification network. But with anomaly detection, you give it good images, you tell it over and over again, hey, this is the right part. Oh, it's in this different orientation this time. It's still right. And it will learn what is anomalous, right? Exactly in the name, anomaly detection. So it'll trigger, oh, hey, this looks something off, kick it to another part of the process and have someone look at it. So it can assist humans in getting a better idea of what's going wrong with their products and catching those products before they get to customers.